Good morning, all. I am Syed Ali FATHYMA, studying 3rd BSc Computer Science from St. Anthony's College of Arts and Science for Women. I am also a student of Junior IAS Academy. Today, we are going to see about entity relationship model in database management system. Before we are coming into a topic, we should know what is data, what is database, and what is entity. First, we will see about the data. Data in computing, data is information that has been translated into a form that is efficient for movement or processing. Here, data is nothing but the information. It gives the information about the particular thing. For example, if we take the student mark list means, in the student mark list, it gives the information about the student. We will see what is database. A database is a collection of data that is organized, which is also called structured data. It can be accessed or stored in a computer system. It can be managed through a database management system, a software used to manage data. Database refers to related data in a structured form. Here, database is nothing but it's a collection of some data, but in the collection of data we are storing the data in the database. So here database is a particular software. In this software we can store all our datas, related datas. We can store it and we can edit the datas. What are the datas that we are need to delete or add? We can do the editings in the database software, and we can also store the data in the database. We need to know what is entity. An entity may be an object with a physical existence, a particular person, car, house, or employee, or it may be an object with a conceptual existence, a company, a job, or a university course. So, entity is nothing but a physical existence means we can take that example as car, person, likewise. But in conceptual existence means we can take it as company, job, like that we can take. Real life means we can take the physical existence. Technical means we can take it as a company and job. So, an entity is an object of entity type, and set of all entities is called as entity set. So, entity means nothing but object, but the object of entity type and the set of all the set of entities is nothing but the entity set. So, here we can see the example. Here in the oval shape we are having three entities, E1, E2, E3. So, these are the entities. We have several entities within that. So, that is that entity set. Entity type means single entity specified with a name. That is entity type. Next we will see about the attribute. Attribute are the properties which define the entity type. For example, roll number, name, date of birth, age, address, mobile number are the attributes which defines the entity type student. Attribute is nothing but the it gives some definition about that student. So here entity type is student, so we are saying a student. So it will give some definition. Definition means it will give some more details about that student. So in this example they have given those details: roll number, name, date of birth, age, address, mobile number. So these are that particular student's details. So it gives some details and definitions about that particular student. So this in ER diagram the attribute is represented by an oval. So in this attribute we have several types. So we will see those types. First type is key attribute. The key attribute which uniquely identifies each entity in a entity set is called key attribute. For example, roll number will be unique for each student. In ER diagram, key attribute is represented by an oval with the underlying lines. So here key attribute means that that single attribute will identify the particular student among each common thing. So if we are taking the student list means in that student list we will have the student with a similar name and a similar thing. So if we have similar thing means we need to identify that particular student specifically means we can use this key attribute. So in that roll number of each student will be unique. So that is this here primary key. So we are using this primary key concept for key attribute. So we can uniquely identify using this key attribute. And here the attribute is represented by the oval with underlying lines. Oval with underlying lines. Like that only here the representations are given, that is roll number. Here roll number we are taken. Next one is composite attribute. An attribute composed of many other attributes is called as composite attribute. For example, address attribute of student entity type consists of street, city, state and country. Here composite attribute is nothing but it itself comprised of many other attributes. Within a single entity we have several types, several divisions, subdivisions. So that thing is composite attribute. For example, we can see here in the student entity type we are having address attribute. So with that address attribute itself we have several division. The student belongs to which street, which city and which state and which country. Simply we are saying address, within that we are having these subdivisions. So these subdivisions are comprising. So this single address comprising of these subdivisions. So this is known as composed attribute, and in the ER diagram the composed attribute is represented by the oval comprising of oval, that is subdivisions we can understand. Next one, multi-valued attribute. An attribute consisting more than one value for a given entity. For example, phone number can be more than one for a given student. In ER diagram, multi-valued attribute is represented by double oval. Here, in the multi-valued attribute, for a single attribute itself, we are having more values. For example, the student can give the number of both her father and mother and her home. Like that, she can give more numbers to the particular details. For that, she can give more numbers. So for a single attribute itself we are having more values. So that is here multi-valued attribute. Next we will see about the derived attribute. An attribute which can be derived from other attributes of the entity type is known as derived attribute. Here the attribute is deriving from another attribute. We can understand with the example clearly that age can be derived from date of birth. Here for a particular person we can identify their age using their date of birth. With the date of birth only we are identifying their age. So the age is derived from the date of birth. So that is here derived attribute. In the ER diagram the derived attribute is represented by the dashed oval. The complete entity type student with its attribute can be represented as. So we can see the total thing about this entity. So here student is an entity. Here roll number is an attribute. That attribute we can say it as key attribute because that uniquely identifies. Then name is another attribute. Age is the derived attribute as it derives from the date of birth. And phone number is a multi-valued attribute because it has more than one values, and date of birth is also an attribute. And then next, address is a composite attribute. With the composite attribute here, in that address itself it comprising of lot of vowels. That is, in that address itself we are having country, city, state and street. So that is here address, that is composite attribute. Next we will see about relationship. The logical association among entities is called relationship. Relationship are mapped with the entities in various ways. Mapping cardinalities define the number of association between two entities. Here we will specify the relationship with the help of map. So with the help of the mapping representation we can understand this relationship. So in mapping cardinalities we are having four types: one to one, many, one to many, many to one and many to many. First we will see about what is mapping cardinalities. Mapping cardinalities defines the relationship between the number of entities in one entity set with the number of entities to other entity sets. It is nothing but the relationship between one to many. Like that, among the types it will vary. So for one to one we can say it as its name implies, it maps one entity of the first entity set with another one in the second one entity set. In the below image, this has depicted that one entity from entity set A is associated with the at most one entity of other one entity set B. So here in this picture we can understand it clearly. In this picture here we are having one entity set and here also we are having one entity set. So here one to one means the one entity of A should be connected with the one entity of B. Like that only we should connect. Okay, so that is a one to one entity. For example, we can have a customer has only one ID. Yes, a customer should have only one ID. So here customer is also a single person and ID is also a single thing. So one customer can have only one ID. So that is here one to one relationship. The next one is one to many. An entity from set A can be aligned with more than one entity from set B, but an entity from set B can be associated with a limit of one entity. So here one to many means, in this picture we can understand that first entity we are having, so from that we should relate with more entity. So from the entity A we can relate with the more entities of set B. Okay, from the, for example, we can see that a customer may place many orders but many customers do not place an order. So here customer means that represents a single person. So customer placed, here placed is the relationship, placed order. So single customer can place many order. So that is we can do, that is possible. So here one to many relationship. Next one is many to one relationship. More than one entity from set A could be paired with a maximum of one entity set B, but more than one entity from set B can be paired with a maximum of one entity from set A. Here many to one is nothing but from the entity set A, we are connecting with the entity set B, but we are connecting more entities of A to single entity of B, more entities of A to single entity of B. So for example we can identify with this example. Here customer's entity and order is also an entity. Here many customers may place one order. customers they have given. So here many customers can place one order. That means many customer can buy a single with a single order. So that is here many to one relationship. Next we will see about many to many relationship. It is possible to connect one entity set from set A with more than one entity from set B and vice versa. In this many to many relationship, we are relating more entities from the entity set A to more entities from the entity set B. That we are connecting, that is many to many relationship. In this example, we can understand clearly that many customer may place many orders. So here they have given many customers. So here lots of customers are placing more orders. Yes, we can more customers can place more orders. So that is here many to many relationship. Thank you all.